Hi everyone, so this is the last lesson that we will do on factorising expressions, and in this lesson we will be looking at some really tricky expressions that involve or that have indices. So we'll look at some examples first, and you should copy these examples into your book so that you can look back on them when you're doing your own work. So this first expression we'll look at is x squared plus 6x, and we want to write all the factor pairs for this expression and then decide which expression is the fully factorised expression. So our first factor pair would be taking out just a factor of 1. The next factor pair would be taking out a factor of x, because x appears in both of these terms. So I can take out a factor of x in both terms. And that means inside my brackets, when I do x squared and I take out a factor of x, so I've got two x's and I take out a factor of x, that leaves me with 1x. And positive 6x, when I take out a factor of x, gives me just 6, sorry. So the fully factorised expression here for this one would be when we take out the greatest possible factor, so it would be the bottom one here, which is x bracket x plus 6. In the next example, we have x cubed plus 6x squared. So a similar question. So I'm going to start by writing my factor pairs. I can take out a factor of 1, nice and easy there. Next, well, I can't take out any numbers, but I can take out a factor of x from both of these terms, because x does appear in both terms. Now x cubed, take out a factor of x, gives me x squared, because I've got 3 x's and I take out 1, that leaves me with 2. And then plus 6x squared, if I take out one of the x's, that leaves me, well, 2 x's, take out one of the x's, gives me just 1x left, so plus 6x. But notice on this one, because I have 3 x's here and 2 x's here, all multiplied together, so x cubed and x squared, I can actually take out x squared. I can take out, divide through by x squared for both of these terms. Now, x cubed divided by x squared, well, that's just going to leave me with 1x left. And then plus 6x squared, if I take out the x squared, gives me just plus 6. So the fully factorised expression for this one is when I take out the greatest possible factor, so again it will be the last one, to give me x squared bracket x plus 6. Next example. Here I have 2x squared plus 6x. So I can do my first factor pair as always, take out a factor of 1, that one's nice and easy. Sticking with my numbers, I can see that I can also take out a factor of 2 here, and that would give me x squared plus 3x. We're now going to look at taking out some variables, so actually I can see that x appears in both of these terms, so I can take out 1x. And when I take out 1x, well, 2x squared divided through by x, if I take out a factor of x, gives me just 2x. I had 2, I divided through by 1, and that left me with 1. And then plus 6x, if I divide out by the x, if I take out the x as a factor, that leaves me plus 6. You might think we should stop here, but actually there's something even bigger I can take out from both of these terms. I can actually take out 2x. Okay, so if I do 2x squared and I divide through and take out a factor of 2x, well, that's going to leave me with just x left over. And so I've divided through by the 2, I've got x squared divided through by x, that leaves me with just one of the x's left. And then plus 6x, well, if I divide through by 2, leaves me 3, and x divided through by x cancels out, so I have just plus 3 here. So the fully factorised expression, again, is when I take out the greatest possible factor. So for this one, it's 2x bracket x plus 3. And the last example, we have 2x to the power of 5 plus 6x squared. Now, I'm going to start off by taking out my easiest factor, just 1. Then I will be able to take out also a factor of 2 from both terms, and that will leave me with x to the power of 5 plus 3x squared. I'm now going to think about taking taking out the variable x. So if I take out x from both terms, well, 2x to the power of 5, if I divide through by x and take x out as a factor, well, that will only leave me with 4 x's multiplied together. So I will have 2x to the power of 4, because I've taken 1 out. And then if I take one of the x's out here, if I divide through by x, that will leave me with just plus 6x. I can actually also take out a factor of 2x here. If I take out a factor of 2x from 2x to the power of 5, well, the 2 will be divided through and will cancel out, and x to the power of 5 divided through by x will leave me with 4 of them. So x to the power of 4 is what I get when I do 2x to the power of 5 and I take out a factor of 2x. Plus 6x squared, well, if I take out a factor of 2x, if I take out a factor of 2 from 6, then I get 3, because 6 divided by 2 is 3. And if I take out a factor of x from x squared, well, that leaves me with just 1x left. I can actually go even bigger with this. I can take out some larger factors from both terms. I'm going to try and take out a factor of x squared. I'm going to divide through, I'm going to take out 2 x's from both terms. So 2x to the power of 5, if I divide through by x squared, take out a factor of x squared, well, that's going to lower this number here by 2, isn't it? Because I'm taking 2 out. So that leaves me with 2x cubed. And then plus 6x squared, if I divide through by x squared, take out a factor of x squared, then, well, my x squared is going to disappear because I've taken it outside the bracket. So that's just going to leave me with plus 6. Lastly, the greatest factor possible that I can take out of both of these terms in this expression is 2x squared. I can take out the greatest possible number and the greatest possible letters. So when I take out 2x squared, well, the first term, if I take out a factor of 2, then my 2 will disappear. X to the power of 5, taking out a factor of x squared, will leave me with x cubed. So my 2 has cancelled, as you can see, and my x to the power of 5, well, I've taken out x to the power of 2, so that will leave me x to the power of 3. And then 6x squared, well, if I divide through by 2, that leaves me with 3. And x squared divided through by x squared leaves me with nothing. I've taken it out. So my fully factorised expression for 2x to the power of 5 plus 6x squared would be 2x squared bracket x plus 3. Because this is the expression where I took out the greatest possible factor. So here I have 1, 2, 3, 4, 5 expressions. Now, for each expression, I've given you 4 options. And I want you to choose, for each one, choose the correct greatest factor that is outside the bracket in each case. So for this one, you need to choose which of these 4 options has the greatest possible factor outside of the bracket. There is one correct answer for each. So pause the video now and have a go. Okay, so for the first one, the greatest possible factor we can take out for the first one is x squared, because, well, we can't take out a number because we've got 3 here and we don't have anything here, so we definitely can't take out 3, so that eliminates this one. Now, it is possible to take out a factor of x, like the first option, but actually, because we have x cubed and x squared, the biggest possible option is x squared, isn't it? Now, x cubed is incorrect because even though we have x cubed here, so it's possible to take out x cubed from the first term, the second term only has x squared, so we actually don't have enough x's here to take out x cubed. So that's why this one is correct. In the next one, the correct answer was 3x squared. Now, all of these different options recognise we could take out a factor of 3, which is great. Now, the reason why the first 2 are wrong is because, yes, we can take out 3, and yes, we can also take out 3x. But the greatest possible power of x that we can take out is x squared, because we've got 3 available here and 2 available here. So that means the greatest possible we can take out of both is x squared. This last one is incorrect because we've taken out x cubed, and that's just not possible, because even though we have x cubed in the first term, the second term doesn't have x cubed. It doesn't have 3 x's available for us to take outside the bracket. So that's why the last one's wrong. The next one, the correct answer is 3x cubed outside of the bracket. So going through this one, we can definitely take out a factor of 3 from 9 and 3. So the middle two, we immediately know are not right, because we should be seeing a 3 outside of the bracket for sure. Now the first one is incorrect, because even though it has taken out a factor of 3, it's only taken out at 1x from both of these terms, and that's not the greatest possible, is it? Because we've got x cubed here and x to the power of 5 here. So we can take out more than 1x. We can actually take out a maximum of 3. So 3x cubed is the greatest factor to take out of those two terms. In the next one, the correct answer here is 4x cubed outside of the brackets. Now, we definitely know that we should be seeing number 4, because 16 and 12 have a highest common factor of 4, so that means the first one is definitely wrong, because we should see a 4 here. Now the next 3, we can see a 4, so let's decide which one is the correct one. Well, the first one's it has taken out a factor of 4, great, but it's only taken out 1x. And it's possible to take out more, isn't it? Because we've got x cubed here and x to the power of 4 here, so we have actually, between the two of these, the largest possible one we can take out is x cubed. Now, the last one's incorrect because it's taken out x to the power of 4, and in the first term we just don't have that many x's. We don't have that many to take out. Okay, and the last one, we have 4x outside of the bracket. So, looking at these two numbers, first of all, 16 and 12, the highest common factor between those two is 4. So that means we should be seeing a 4 outside of the bracket. Now that means the first one is incorrect and the second one is incorrect, because this has not taken out a number at all, and this one has only taken out 2. But the greatest, highest common factor is 4. So that leaves us with the last two to decide between these two, and the last one we can see is taken out x squared, which would be fine for the first term because we do have x squared here to take out, but in the second term we only have x to the power of 1, or just 1x. So actually it's not possible to take out x squared from this term, which is why the greatest possible factor is 4x. Okay, hopefully that helps you to see how we decide what the greatest factor is that we can take outside the bracket. So what I want you to do is pause the video, and now I want you to fill out what expressions go inside of the brackets for those 4 questions. So these are the 4 correct answers that we just went through, and now I want you to fill out what goes inside the brackets. So pause the video now and have a go. Okay, so right, we'll go through the answers now. So make sure you mark this in a different colour pen. Any corrections, write out in your different colour. Okay, so the first one, we've taken out a factor of x squared from both terms. So when I have x cubed and I take out a factor of x squared, or I divide through by x squared, that will leave me with just x. And when I do 3x squared and I take out a factor of x squared, or plus 3x squared, take out a factor of x squared, well, I've completely taken it out, haven't I? So that means I just have plus 3 inside, x plus 3 inside my bracket. For the next one, we decided the greatest possible factor to take out was 3x squared. So for the first term, if I take out 3, so 9 take out 3, 9 divided by 3 should give me 3. And x cubed divided by x squared should leave me with just x. So I should get 3x as my first term inside the bracket. And then when I do 3x squared divided through by 3x squared, so 3x squared take out 3x squared, well, that's just 1. 3x squared divided by itself is just 1. So 3x plus 1 goes inside the bracket there. Okay, next one, the greatest possible factor to take out was 3x cubed, because 9 and 3 have a highest common factor of 3, and x cubed and x to the power of 5 have a highest common factor of x cubed. So we took out 3x cubed. Now 9 divided by 3 gives me 3, and x cubed divided by x cubed cancel out. So I just have 3 here for my first term. And then for the next term, when I do 3x to the power of 5, if I take out 3, well 3 divided by 3 is 1, so I don't have any number here, it's just 1. And x to the power of 5, take out x to the power of 3, well that's x squared, because x cubed multiplied by x squared will give me x to the power of 5. So I've taken out 3 of those x's, and that's left me with 2. Okay, in the next expression, we took out a factor of 4x cubed. So to decide what goes inside the bracket, for the first term we have 16, and we'll divide that by 4 to get 4. And x cubed divided by x cubed will just cancel. So I'll have just 4 here. And then plus 12x to the power of 4, if I take out 4x cubed, well, 12 take out 4 gives me 3. And x to the power of 4 take out x to the power of cubed leaves 1x left. So plus 3x is what we get from the second term. So 4 plus 3x is inside the bracket. And the last one, we decided to take out 4x. So 16 divided by 4 gives me 4, and x cubed divided by x gives me just x. So I get 4x from the first term, and then 12 plus 12x divided by 4x gives me just 3, because 12 divided by 4 is 3, and x divided by x cancels. Okay, here are 4 questions, okay, that I've completed, and there is one error in each question. So I want you to pause the video, and I want you to try and spot the error in each expression that's been fully factorised, and then give the correct answer as well. So you're spotting the error and giving the correct answer. So pause the video now and off you go. Okay, so in the first one, the error is that we could have taken out a greater factor than d. We could have taken a greater factor than d outside of the bracket. Here we have d to the power of 4, and here we have d to the power of 3. Now I've only taken out d here, 1d, but I could actually have taken out a maximum of 3. I could have taken d cubed out of both of these terms to give me d cubed bracket d take away 1. Okay, next one, the mistake here is that when we take a factor of d squared outside of the bracket, so that was the correct choice, that was the greatest possible factor to take out, the d squared. But when we take out a factor of d squared, our first term inside the bracket should be d squared and not d. So it's this here that's the mistake. When we take a factor of d squared outside of the bracket, d to the power of 4, take out d squared, or 2 of those, leaves me with 2 left. So I should have d squared here, rather than just 1d. So d squared bracket d squared take away 1 is the correct answer. Okay, next, the error here is that the greatest common factor to take outside the bracket should be 10d squared. And this will then affect what's inside the brackets too. So here I've decided to take out 2d squared. Now the d squared part is correct, because d to the power of 4, d to the power of 2, the maximum I can take out of both is 2, d squared is just d squared. But 20 and 10 have a highest common factor of 10, not 2. So actually I should see 10d squared outside the bracket, and then that will affect what's inside the bracket too. So when I take out 10d squared from the first term, 20 divided by 10 gives me 2, and d to the power of 4 divided by d squared gives me d squared. And then minus 10d squared divided by 10d squared gives me minus 1. Okay, and the last one, the error, is that the subtract has been switched to a plus inside the brackets. This is a really small but common error that pupils make all the time. They've taken out the greatest factor correctly, excellent. They've got 2d squared correct, they've got 1 correct. Oh, my answer isn't right. This should be a minus. I obviously forgot to change it in my answers. Sorry about that, guys. But this should be 2d squared take away 1. It's not a problem. You can just mark it correctly in your book. Okay. Practice questions 2. I want you to fully factorise each of these expressions. Pause the video now and have a go. Okay, we're going to go through the answers, so get a different colour pen and make sure you are marking the work. Any mistakes, make sure you make a note of them. So in our first one, the highest factor we can take out of both is just r, and that leaves us with 1 take away r squared inside the bracket. Next, the greatest possible factor we can take out is actually r squared. So we take r squared outside the bracket, and that gives us 1 take away r. Next, the greatest possible factor we can take out is r cubed, because we've got 5 here, 3 here. So we can take out r cubed, and that will give us r squared minus 1 inside the bracket. Next, the greatest possible factor again we can take out is r cubed, and that leaves us with r squared plus 1 inside the bracket. These two are the same, aren't they? Just a negative and a positive. And the last one, if I look at all three terms, r to the power 5, r to the power 3, r to the power 4, the greatest possible, the highest common factor and the greatest possible thing I can take outside my bracket here would have to be r cubed, because that's kind of limiting what I can take out, isn't it? It's the smallest one. So if I take out r cubed, that leaves me with r squared plus 1 when I do r cubed divided by r cubed, and take away r in the end. Okay, have a go at these 5 questions. Pause the video now. Okay, so we're going to go through the answers, make sure you have a different colour pen to work with. So we now have numbers involved, so we need to think about numbers and letters here. So 12k, take away 8k cubed, the greatest possible factor there would be 4k. 4k. Now when inside the bracket we get 3, take away 2k squared. Next, we have 12 and 18 as our numbers, so the greatest possible number would be 6 this time, and k and k cubed, the greatest possible letter we could take out is just k. So we take out 6k, and that leaves us with 2, and then minus 3k squared from the second term. If we look at the next one, we have 12k squared take away 18k cubed. So the greatest possible number we can take out is 6, and the greatest possible letter we could take out is k squared. So we'll take out 6k squared. Now when we take out 6k squared from the first term, that leaves us with just 2. And for the next term, if we take out 6k squared, that leaves us with 3k. Next, we have 3 terms to look at here. So we'll first think, what's the greatest possible number? Well, 12, 18, 24. Again here, the greatest possible number I can take out is 6. And now I'll think about the greatest possible letter. So k cubed, but no letter here. So actually, I can't take a letter outside of the brackets. I can only take 6 outside the brackets. So I get 6 bracket, 2k, take away 3k cubed, plus 4. And the last one, I'll do the same process. I'll look at my numbers. So 12, 18, 24. The greatest possible number again is 6. And now I'll look at the letters k, k cubed, r. So actually there isn't a letter I can take out of all 3 terms. So again, I can only take 6 outside the bracket. And I end up with 2k, take away 3k cubed, plus 4r. Okay, if you thought those were tricky, we're going to look at some even trickier ones now. Now we are working at a really high level at this stage, so if you're finding this difficult, don't worry, because it is difficult. Just persevere, make notes, and it will all make sense, and the more we practice these types of questions. So, I've got 5 questions again, 5 algebraic expressions at the top, and you have 4 options for each. You need to decide once again, you need to choose the greatest factor that's outside the bracket for each case. So pause the video now and have a go at these. Okay, so we'll start to go through the answers. So the first one, the correct answer is a squared b outside the bracket. We'll think about why that's correct. So if I look at these terms, they've both got a and b in them. So I can definitely take out a's and b's, which means this bottom one is wrong, because I can definitely take out a's and b's. It's just a matter of how many. In fact, that's why the second one's wrong as well, because I can definitely take out b's from both terms. So these two are both wrong, because we definitely know we can take out a's and b's. Now, why is this one wrong then? Because we've taken out ab here. Well, the reason why this one's wrong is because let's look at the number of a's and the number of b's we have to work with. Here I have a cubed in the first term, and I have a squared in the second term, so the maximum possible a's I can take out is a squared. Now, in the first term I just have b, in the second term I just have b, so I can only take out one b, but I can actually take out a squared, which is why this one's right and this one here is wrong. Okay, the next one. These are tricky, aren't they? The next one, I've got let's look at the correct answer first actually. Okay, so the correct answer here was a squared b as well. So let's think about why the others are wrong. So again, because we've got a's and b's in both terms, we should be seeing a's and b's outside the bracket. That's why the first one was wrong. Now let's think about why the other two are wrong. Well, we need to think about the maximum possible a's we can take out and the maximum possible b's, and literally look at them one by one. So if I look at my a's first of all, well, I've got a cubed and I've got a squared. So the maximum possible a's I can take out is a squared. And these two here have only taken out a. So they're immediately incorrect if we just consider the a's. Let's consider the b's though, just to make sure that they're both, just to confirm in our heads they're wrong. Well, this one has b and this one has b squared. So the greatest possible b's I can take out is just b here. So that's why this last one is also wrong, because this one's taken out b squared, and that's just not possible because we don't have b squared available in the first term. Next one. Correct answer here is a cubed b, so we'll think about why the others are incorrect. Again, this expression has a's and b's in both terms, so we should see a's and b's outside the bracket. That's why the first one is wrong. Now to decide out of the next three, we already know the last one's right, but to help us discern out of these three which one's correct, we consider the a's and b's separately. So if we look at the a's, I've got a cubed in the first term and a cubed in the second term. So the maximum I can take out is a cubed. And that's why this one is wrong, because this one's only taken out one a when I should be seeing a cubed. Now that leaves us with the last two, so let's look at the b's to help us. Here I have just b, and here I have b squared. So the maximum possible b I can take out is just one b, just over here, one b by itself. And this one has taken out a b squared, which is why it is incorrect. Even though it's taken out a cubed, which is correct, it has taken out b squared, which is not possible. So the last one is wrong. Next, the correct answer is the top one, 4a cubed b. So to decide, the way I would decide that is I would look at the numbers and then each of the letters one by one. So first look at the numbers. I've got 12 and 8. Well, the highest common factor of 12 and 8 is 4, so I should see a 4 outside the bracket, and in all of them I do. So all of these numbers here are correct. So now we'll look at the a's, and then we'll look at the b's, but we'll look at the a's first. So I've got a to the power of 5, and I've got a to the power of 3. So the greatest possible a's I can take out is a to the power of 3. And that's why this one here is wrong, because it's only taken out one a. It's also why the last one is wrong, because this one's taken out a to the power of 5, and that's just not possible because in the second term we don't have a to the power of 5 available. So we're then left with this one, our correct answer, and this one, because they've both taken out 4, they've both taken out a cubed. So now we'll look at the b's. So b, we have just b by itself here, and we have b squared. So the greatest possible b I can take out is just 1. And this one's taken out b squared. It's just not possible, is it? Because in the first term we don't have b squared available. So 4a cubed b is the correct answer to take, the correct greatest factor to take out of the bracket. Last one, super tricky. So we'll look at the numbers, we'll look at the a's, we'll look at the b's, we'll look at the c's, all in that order, and it will help us decide on the correct answer. So in fact, I'm not going to reveal the correct answer here. We're going to work through by process of elimination. So 6 and 8, we'll look at the numbers first. 6 and 8 have a highest common factor of 2, so we should see 2 outside the bracket, and in every single one we do. So the numbers aren't going to help us decide which one's correct, because they're all correct when we just look at the numbers. Let's look at the a's. Here I have a to the power of 5, here I have a to the power of 3. That means the greatest possible a's I can take out are a cubed, right? Because I've got 5 of them, 3 of them, the greatest possible to take out is 3. So that means the first one is wrong, because they've only taken out 1. The second one is wrong, because they've taken out a to the power of 5, and that's just not possible, because we don't have 5 available in this term. So now we're down to the last 2. So we'll look at the b's. Now, the b's. I've got 1b here, and I've got b squared here. So the greatest possible b's I can take out is just 1. So looking at these 2 that I'm left with, well, this one has taken out 2, it's taken out b squared. But that is not possible because the first term doesn't have b squared available. So it has to be the last one, because that one has correctly taken out b. We'll just double check that it's correct by looking at the c's. In our first term we have c cubed, and our second term we have just c. So the greatest possible c we can take out is just 1c. So this one is fully correct, the bottom one there. 2a cubed bc, outside the bracket. So, like the other examples, practice questions 3, you're going to fill out the expressions that go inside the brackets here. So pause the video now and have a go. Okay, so we'll go through the answers to these. When I take a squared, so what I would do is I would go through my letters one by one. Okay, so I've taken a squared outside of the brackets. So if I take a squared out of the first term, that will leave me just a, and a squared out of the second term will cancel. I've taken b outside of the bracket, so b, if I take b out, that leaves me with no b's, and b, if I take b out, again, that leaves me with no b's. So I have a plus 1 inside the bracket. Interestingly, a squared b, if I take out a squared b, it's just 1, because a squared b divided by a squared b is 1. Okay, next we have a cubed b plus a squared b squared. So taking out a squared b, so I'll show you the answer, but go through it. So a cubed take out a squared leaves me with 1a, and b take out b leaves me no b's. A squared take out a squared leaves me with no a's, and b squared take out b leaves me with b. So I get a plus b inside the bracket. Next, show you the answer. We'll go through it. For the first term, a cubed take out a cubed, cancels. B take out b, cancels. So I'm left with just 1. A cubed take out a cubed, cancels. B squared take out b, leaves me with b. So in this one I have 1 plus b inside the bracket. Next, these super tricky ones. We'll do the numbers and then we'll do the letters. So 12, we took 4a cubed b outside the bracket. 12 take out 4 gives me 3. A to the power of 5 take out a cubed gives me a squared. B take out b, cancels. 8 take out 4 gives me 2. A cubed take out a cubed, cancels. And b squared take out b gives me b. So 3a squared plus 2b goes inside the bracket. Last one. Show the answer and go through it. 6 take out 2 gives me 3. A to the power of 5 take out a cubed gives me a squared. B take out b, cancels. C cubed take out c gives me c squared. Next term, 8 take out 2 gives me 4. A cubed take out a cubed, cancels. B squared take out b gives me just 1b. And then c take out c, cancels. These are super, super tricky. So if you found those hard, don't be stressing yourselves out because they are hard. Okay, here are some practice questions for you to have a go at. So pause the video now and have a go at these by yourself. You're fully factorising each expression. Okay, so in our first expression, we can take out a maximum of just s from both terms, and that gives us s t to the power of 4 plus s squared. Next, why does that come up? Oh well. Next, we can take out s and t from both terms to give us t cubed plus s squared. In the next one, the maximum s we can take out is just 1s, and the maximum t we can take out is t squared. So that's going to leave us with t squared plus s squared. Next, the maximum s I can take out is s squared, and the maximum t I can take out is just t. So I took out s squared t. Then that leaves me with t squared plus s inside the bracket. Next, the maximum s I can take out is just 1s, and the maximum t's I can take out is t to the power of 4. So I've taken out st to the power of 4. That leaves me with 1 plus s to the power of 4t in the bracket. Here are 5 more questions for you to have a go at, so pause the video now and have a go at these. Okay then, so for the first one, the maximum thing I can take outside the bracket, well 6 and 3, that means I can take out 3, I can take out m, I can take out n, and I can take out o. So 3 m n o is outside the bracket, with just n plus 2 inside the bracket. Next, I can take out 3, looking at the numbers, I can take out m, I can take out n, and I can take out o. So 3mno, and then inside the brackets is m squared n plus 2. Next, looking at my numbers, I can take out 3, I can take out m squared, I can take out n, and I can take out o. So 3m squared no is outside the bracket with mn plus 2 inside the bracket. Next, 30 and 6, well I can take out 6 from there. I can take out m, I can take out n, and I can take out o. So 6mno is outside the bracket with 5m squared inside the bracket plus n squared o squared. And the last one, I can take out 6, I can take out m, I can take out n squared, and I can take out o. So 6mn squared o, and then inside the bracket I will have 5n to the power of 6 plus no squared. So these questions are really tricky, and if you found them hard, don't beat yourself up about it. They are very, very hard. So this is the end of the lesson. Well done. Make sure everything, all of your answers are checked in a different colour with any corrections written in.